Hello everyone, welcome to another session of DC circuits. In this particular session, we would be covering the Kirchhoff's laws. In 1847, G.R. Kirchhoff extended Ohm's law to another two laws. The first law was named after his name as Kirchhoff's current law, which is also known as the point law or the junction law. The second law was named as the Kirchhoff's voltage law or the mesh law. It is also known as the loop law. We will go through these laws one by one. पहला हम लॉ करते हैं Kirchhoff's current law. Kirchhoff's current law के according, the sum, that is algebraic sum. When we are talking about algebraic sum, it means considering the sign convention as well. The algebraic sum of all the currents entering and leaving the node is the zero. We can also define it like total current flowing into the junction is equals to total current flowing out of that particular junction. For example, in the given circuit, we have three resistances connected in parallel, R1, R2 and R3. Across these three resistances, we have applied a single voltage source, that is ET. The total current that is being generated through this particular voltage source is IT. When the IT is reaching point A, that is node A, then this particular current is divided into three parts, that is I1, I2 and I3. According to Kirchhoff's law, the total current, that is IT, will be equals to I1 plus I2 plus I3. Let's understand this with the example. In this particular example, we have to calculate the nodal voltage, that is VA, and current across the 2 ohm resistance. In this particular circuit, we have two voltage sources, 5 volts and the 8 volt, three resistances, 4 ohm, 6 ohm and 2 ohm. How we will be using the Kirchhoff's current law to identify the current across the 2 ohm resistance? Let's start. First of all, apply KCL at node A. Then current entering is denoted by I1. Current leaving the node are denoted by I2 and I3. According to KCL, I1 would be equals to I2 plus I3. Using the potential differences and the resistances, this particular equations can be written as I1 can be written as 5 minus VA divided by 4, whereas I2 can be written as VA minus 0 potential. Why? Because the second terminal of 2 ohm resistance is connected to ground. VA minus 0 divided by 2. The current across the third resistance, that is I3, can be given by VA minus 8 divided by 6, that is the value of third resistances. Accordingly, we can solve this particular equation and we can calculate the value of voltage at node A, which is coming out to be as 2.81 volts. So, to determine the current across the 2 ohm resistance, we can use the equation VA minus 0 divided by 2. The voltage at node A is known to us now. What is the value? That is 2.81 volts. 2.81 divided by 2, it is coming out to be as 1.405 amperes. That is the value of current across the resistance R2. So, in this particular manner, we have used the Kirchhoff's current law to identify the current across one of the resistance in this particular problem. Next law is the Kirchhoff's voltage law. According to Kirchhoff's voltage law, algebraic sum of all the voltages in the closed loop, this condition is very much necessary, in the closed loop will be equals to 0. When we are talking about sum of all the voltages, this implies either it is a voltage source, this may be considered in the positive convention, and the positive voltage drop will be considered as the negative. So, according to Kirchhoff's law, algebraic sum of all the voltages around a closed circuit will be equals to 0. Alternatively, we can also define the Kirchhoff's voltage law as sum of all the voltage sources in a closed circuit will be equals to all the voltage drop in the electrical circuit. In the given circuit, we have the three resistances R1, R2 and R3 given by our input voltage ET. So, ET will be equals to E R1 or E1 across the resistance R1, E2 across the resistance R2 and E3 is the voltage drop across the resistance R3. So, according to KVL, ET minus of E1 minus of E2 minus of E3 will be equals to 0. In this particular manner, we can use the KVL also to solve the numerical problem. So, let us proceed with a problem, and in this particular problems we will be using the Kirchhoff's voltage law. A series resistive circuit is connected to a 12 volt voltage source with a resistance of 4 ohms in the circuit. So, here we have to identify what is the total voltage drop in the electrical circuit. If the total resistance is only 4 ohms in the electrical circuit and input voltage source is 12 volt, then the current flowing through the circuit is given by Ohm's law, that is equals to 3 amperes. The voltage across the resistance, that is 4 ohms, will be equals to 12 volt only. Alternatively, if the value of resistance is not mentioned, then also the complete source voltage is the voltage drop across a single resistance value, that is a 12 volt. Next question is, a series circuit is connected to a 12 volt voltage source with 3 resistances. One resistance drops 3 volt, another resistance drops 5 volt. What would be the voltage drop across the third resistance? According to KVL, sum of all the voltage sources on voltage drops, algebraic sum, will be equals to 0. So, in this particular value, we are considering the input source to be as the 12 volts. The voltage drop across one of the resistance is 3 volt, second resistance is 5 volt, and we have to identify the voltage across the third. So, according to KVL, 12 minus 3 minus 5 minus E3 will be equals to 0. From this, we can easily identify the value of voltage drop across the third resistance, that is 12 minus 8 is equals to 4 volt. So, the answer is the voltage drop across the third resistance is 4 volts. What if a series circuit has two identical resistors connected in series with a 9 volt battery? What would be the voltage drop across each of the resistances? So, here the two resistances are said to be identical, it means both are equal. Let us assume that both are resistance having the magnitude of R ohms. Then the total resistance in series, it will become twice of R. So, the voltage drop will be equally divided into each of the resistances, and hence the voltage drop across each of the resistance is 4.5 volts across each of the resistance. This is a numerical problem that you can solve and practice at your end. In case of any query, you can reach out to me on my email ID preeti@svsu.ac.in. Thank you very much.